Okay. What you want to do on all of these demonstrations is describe what you see at the beginning, what you see at the end, what happens in between. It's going to help you get evidence to decide whether you see a chemical or physical change. Okay? And there should be, hopefully some of these at least, that stump you a little bit. The hope is that you won't have a clear-cut decision on every one of them. And if you think you have a clear-cut decision, then occasionally you'll find out you go wrong, because that's more fun. It gives us something to talk about next week. All right? We'll be talking about these next week in class. Don't expect that necessarily today we're going to give you all the answers. In fact, we're not going to tell you any of the answers. We are going to have some input from you. This is Townsend's coming around the mic. You should be looking for your input on what you observe, what you think, and why. And we won't sit and tell you if you're right or wrong necessarily, but we'll have you give us some input while we're setting up the next one. Okay? So, this first demonstration, nothing too explosive or anything, but as you talked about here, we've got this blue and white beady bottle. So it's blue and white beads in clear solution or clear liquid. All right? And then what we're going to do is shake it up a little. And in doing that, mix it up. And what happens is there, well, you can see there are blue beads now at the bottom of the bottle, white beads at the top, liquid in between. And that's all fine and good, okay? But let's give it a little time. I'm going to sit on the desk, let it stew for a minute while we set up the next one. You guys keep an eye on it. Is that a verb I didn't know the meaning of? I apologize in advance. From my
it's a noun.
Stew. It is a noun. I have a feeling it's being interpreted otherwise. All right. We'll do our best to pose it to you here so you can kind of watch it do its thing. Okay? So that's going to be number one. Our second one. Let's set up over here. I'm not sure where we're going to go. Let's go with this one next. White tub, a little white foamy cooler. And sweet gray thermos. Does anybody know what this holds? Sorry? Liquid nitrogen, survey says. We have liquid nitrogen in this jug. Observe.
Was this number 2? What's your evidence? Turn them off. Turn them off. I don't know. It seems like I'm zoomed in too far.
Yeah, I zoomed it in.
Pinch it back. There we go.
Okay. Yeah, you can bring the one up again if you want. Well, that's good. Well, we're kind of making what looks like a frozen shake here. But we've got kind of bubbles on top. Liquid nitrogen number 1. There's going to be a few. Okay.
Can you guys see that? Can you see it on the screen? Yeah, I can't see a whole lot. What are we doing now?
Number 3 is called Old Foamy.
Old Foamy.
White powder going in a big old graduated cylinder. Might be a little too much. Some is good, more is better. A little bit of Dawn.
Listen.
And another clear liquid. Anybody know what comes in brown bottle? Hydrogen peroxide. You go to the drugstore or Walmart or something and pick up a bottle of hydrogen peroxide. You usually find it about 3%. 3%, and if you put it in a scrape or a cut, you know, it stings when you're a little kid. Maybe your parents put it on the scrape, and it stings and disinfects and so on. That peroxide's 3% and it stings. This is 27 to 30% depending on the day. This is like 10 times stronger. This is unpleasant on your skin. On a cut, you'd be crying for mama. On your skin, it'd be itching and burning like crazy. A lot of the cuts, we'll see what it does here. So we have white powder. This is on your soap again now for this. Lights all the way up. Probably still lights all the way up. What do you think?
Maybe. Wish we had a spotlight. Oh, oh.
So that's Old Foamy, named after Old Faithful, somewhat. Old Foamy.
Let's
What do you think?
let's get a little feedback.
Let's go back to the first bottle real quick. Okay.
Cody Nolan. Let's talk about this first example we have here with the beads and the two liquids. Shake it up again, show them what happens.
So we have blue beads under white beads, and now we have, right, blue beads still under, but now they're way the heck to the bottom.
Cody Nolan, do you think this is chemical or physical change?
What is chemical?
Why?
I mean physical.
Why?
It changed physically.
Did it change chemically?
Don't know.
What do you think?
Maybe.
Yes or no?
I'm gonna go with yes.
It changed chemically?
No.
So notice along the way we had a blue layer and a white layer. We shake it, the blue layer goes to the bottom, the white layer goes to the top. And now as we wait, we get a point where there's a clear layer down below, there's a clear layer up above, there's a clear layer in between, and there's a blue-white layer separated. So we actually get 5 layers right here. And all we did was shake it. Okay, it got organized, we shook it up and messed it up, it organized itself, and now it's sort of reorganizing itself over time. What the heck is going on in here that causes that to happen? Your physical change versus chemical change decision is up to you. As to why this does this, we'll be talking about it more next week in class and talking about some of the chemistry, what's happening in that bottle. Okay, so that's your first one. Our second one was our
Liquid nitrogen number 1.
Nitrogen number 1, which is it looks a lot like a very airy ice cream in here right now, basically. Yeah.
It looks like the end of a root beer float.
It does kind of, yes.
Tanisha Keeper, you think the chemical or physical with this one?
Chemical.
Why?
Because it doesn't change physically, it changes into something new.
What's your evidence of that?
It is properly changed to produce substance.
Remember we talked about 4 pieces of evidence the other day about what makes a chemical change. When you say this is a chemical change, what is your piece of evidence that something changed chemically here? What's that? It foams, so what do you think it produced? A gas, okay. What about Old Foamy? Why? Because it let off a gas. Alex Russo says chemical because it let off a gas. Raise your hand if you'd agree if chemical let off a gas with Old Foamy. Okay, so we have 3 experiments. Now, moving on to our next one. What do we got here, Mr. Bleff?
We're going to call this one Snow in September.
Snow in September. Snow in September.
Not quite. Don't push it.
Cody, you're not allowed to talk anymore.
All right. You see this okay? Can you see it live okay and up there okay? Or one or the other? See what we got? So we got a white powder. Kind of looks like, I don't know, salt or sugar, okay? And then water. Okay? And mix those together, see what we do. Yeah, this is fine, I guess.
It is snowing in September. Well, a little bit.
I want to get a tub. Spread that out a bit. That's okay. Shoulder. So we went from about 25 milliliters of white powder and 200 milliliters of water to, I'm not sure how much this comes out to be, it's probably somewhere in the neighborhood of about 400 to 500 milliliters of snow. Okay? Much like you'd find on the slopes if you were so inclined to be a skier or a snowboarder. Okay?
Alex Anderson, chemical or physical? Why?
Because it reacted with water and made something different.
What's your piece of evidence that you have something new?
And now I went from like this to big and
So you say it expanded? If something might have expanded, how does it do that? What were the four that we talked about? Formation of precipitate, formation of a gas, energy change. Go ahead, Shania. Do you have something to add? Energy change, formation of precipitate, formation of gas.
Formation of
Precipitate. Precipitate?
Yes.
Good. Shania says formation of a precipitate.
You can feel free to disagree, but...
Yeah, you don't have to agree with Shania or Alex Anderson.
All right, so empty glass bottle, I put a little bit of a solution in there, a clear liquid solution. Doesn't matter what it is right now, but let's call it clear liquid solution. It's a potassium-based compound.
We'll call this the bottle demo.
All right.
What's
it?
it-
This one actually came from Hobby Lobby. So
What's in the bottle?
now it's mostly just water and that other solution. So it's clear liquid. That's all we really care about as far as you're concerned here. Okay. Bottle demo, glass bottle demo.
Bottle demo.
So we have clear liquid here. We have kind of a, you don't drink enough water liquid here. Okay. It's a really dark yellow kind of stuff. So clear and yellow makes light yellow. So this is a classic art class sort of demonstration. And we'll see. So what the heck?
Brother Weeks, are you finding this interesting?
Connie Walter. What do you think, chemical or physical?
Chemical.
Why?
Change color.
Okay, color change. What else? Anything else? Formation of a precipitate. Why do you say that? What's that, Keaton? It got cloudy. So if a clear solution gets cloudy, is it safe to say that a precipitate formed in there? Okay, write it down.
Clear, yellow, red. Not at all what we expect. It's almost bloody red.
Good.
Okay?
What's next, Mr. Bleth?
What do you think? This guy here.
Here's a good one. Oh, this one, I need a close-up of this one.
Sketch on the foot.
Whoa. New beaker. Saved.
We're at the corner. Can I just... So here we've got a peanut butter jar with oil and water in it, just regular oil and water from your kitchen. We'll call this one the peanut butter jar.
Peanut butter jar. Do you hear that echo? Wonder if they can hear it. What? I'm just videoing.
I'm just gonna add a few pellets to this. A little pellets, like a little chewable vitamin for candies or something like that. Let that one percolate and go for a little bit too. Aaron, do you want to flip the lights up? No, the lights back up to like full house. We'll try it. Just not seeing it very clearly.
Maybe shut those. Can we shut the? I can't shut the curtain. Peanut butter jar. Let's hear it. Why do you say that, Isaacoff? Because it what? Okay, so dissolving is example of chemical? Okay. What else? Color change? What else? Formation. What does bubbles mean? Formation of a gas. So we have color change, formation of a gas. Let me ask you this, Isaacoff. Is dissolving an example of a chemical change?
Who argues with him?
Now, okay, let me ask you this, Hoff. Wait a second. What's that? Differing opinion. Go ahead. Alex always has a differing opinion.
Oh, yeah. So what's the question?
Is dissolving an example of a chemical change?
No.
Why?
If you mix sugar and water, that's the sugar's dissolving, but it's not.
If I take the water out of the sugar, is it still sugar? Yeah, so would dissolving be an example of chemical change? Probably not. But would the gas be? Color change? Formation, yeah, we just did formation of a gas. Good, peanut butter jar. I love peanut butter jar.
Put the crackers away and get off YouTube.
We'll let that one sit. It turns into sort of a lava lamp effect after a while, so we'll see if he's still going by the end of the hour. It's kind of gets better as time goes on.
Where are we now?
We call this one flu powder for you powder folks.
What is it?
Flu powder. Not flu like you're sick as a dog.
Do we need this camera right now?
Flu when you don't shoot probably need the camera on this one.
All right, I'm going to take a break.
F-L-U-E.
Flu is where we should be by those kind of things. I have a gas right or something. So, I'm not going to explain this one, it's called, but I have a little bit.
Oh, yeah. Heidi Hills. Oh, Heidi Hills, is this chemical or physical? Huh?
Physical.
Physical. Why? Kovar, what do you have? Chemical or physical? Chemical or physical? Yeah, you. Why? Listen. Go ahead, Kovar. What? What is light? Release of energy, right? Is release of energy a sign of a chemical change? I would say yes. Okay, I'm going to do it. I'm going to go back to the
That's liquid nitrogen number 2.
liquid nitrogen numero 2O. Apparently not. Right?
This is liquid nitrogen number 2.
Flour.
Watch carefully, y'all.
Probably.
Saturday, December, Valentine's Day dreams.
Oh! Another pretty flower.
This is the stuff that the wives of chemistry teachers get on.
Yes. I go home at night, I say, honey, I brought you some flowers. I soaked them in liquid nitrogen. Chemical or physical? Okay. This solution here.
We'll call this a goldenrod paper.
Goldenrod.
Goldenrod.
This solution apparently, I don't know, I've never had it, we just bought it, but if you spray this on your hands for a long enough period of time, your hands actually start to bleed. Yeah, I don't know, I'm going to try it just to see.
Is it bleeding yet?
No, you guys, doesn't look like it. Anyway, we have some goldenrod paper here. Oh, right.
Oh, it is.
Yeah. This is actually called 0.167 molar sodium hydroxide. I did this one for my good friend. Well, I just thought I'd give you some ideas, Wax. Chemical or physical change? I'll write it down. Okay.
Goldenrod. It's called
Goldenrod! You can buy it at your local store. Yeah. You can buy that. I'm really not. Rocket paper! Oh, I love rocket paper.
Rocket paper, this is a very thin type of paper. I won't tell you where it comes from, because you have to go and know where it comes from. We'll open Google and read and graph, figure it all out. Watch carefully. This is called rocket paper. Oh. It looks more like the unmanned ones setting up these days, not something that was nasty.
Did it work?
I'll do rocket paper and then in the classroom, so I use it's a little bit better. It's maybe a little too much. We'll get a little bit better in the classroom. Okay. Let's see.
Okay, new one.
We'll call these little brown bottles.
Little brown bottle.
Little brown bottle.
You guys ready?
German brown bottle. Sure you need this thing.
Ready? Don't. Can you guys see it?
Now, I want you to know we're not touching the clothes, we're not making touch them.
There was no actual physical contact. Can you guys see what's going on? No. Barely. All right. How about I did this? Could you do them both?
I can try it. Got some magazines.
Here we go. Oh, there they go. Yeah. Oh, nothing's burning.
Just open two bottles next to each other and they start to smoke. What the heck? Are you guys catching odor in the front row? No. That's pretty much going straight up.
Not much for ventilation in here.
I like the physical science rules.
Good.
All right.
Creed Clements, looking at that last one, do you think chemical or physical? Chemical. Why Creed? I don't know, because it made... Creed said it made a gas. Who agrees with Creed that we made a gas right there? It's probably one we need to talk about next week.
Wait. Wait. Whoa. Oh, that's not good. What was that? Oh, our tray busted? It's alive. It's alive.
Did we make a gas here, Creed? Did we make a gas? It just smoked. Should we do it again?
Yeah. Go big or go home.
What'd this cost you today? $30. Well worth it, right? Big little. Whoa. Oh.
That thing's wilting away like Legacy's next boys tennis opponent.
Oh.
It's lit. Oh, and it's big again.
We making a gas here, Creed?
Wouldn't we have to be making a gas if that thing's getting bigger? No. No?
Whoa.
Just changing the form.
Are you writing all these down, Dad?
Saith Dan.
I know you
Dale
have great
Earnhardt
ideas.
Johnson.
Anyway, blue balloon.
Blue balloon.
What?